Right now, as you're watching this, a massive storm system is rapidly organizing across the continent. What's happening in the atmosphere today is extraordinary, and what meteorologists are seeing on their radar screens has them genuinely alarmed. This isn't just another weather system. This is shaping up to be one of the most dangerous, severe weather threats we've seen all year. And what makes this particular situation so concerning is the speed at which it's intensifying and the sheer geographic scope of the area that's going to be impacted. We're currently in the middle of August, typically a time when severe weather starts to shift away from the Central Plains and moves northward into the Dakotas and the upper Midwest. But what we're witnessing right now defies that typical pattern. A powerful atmospheric setup is unfolding that has meteorologists at the Storm Prediction Center working around the clock, and for good reason. This isn't speculation or worst-case scenario thinking. This is based on real-time atmospheric data, satellite imagery, and decades of forecasting experience that tells us exactly what's about to unfold. Let me paint you a picture of what's happening in the upper atmosphere first. There's a strong jet stream that's positioned perfectly to interact with a strong upper-level low-pressure system. This isn't random. This is a very specific atmospheric pattern that meteorologists call a negatively tilted trough. Essentially, what this means is that the upper-level winds are oriented in such a way that they're going to drive and sustain severe thunderstorm development for an extended period of time. The jet stream is screaming across the country at 60 to 80 knots, which is exceptionally strong for late August. That's the kind of wind shear you need to organize and sustain supercells. At the surface, meanwhile, a cold front is pushing down from Canada with cold, dry air behind it. But ahead of that front, there's something equally important happening. A warm, moist air mass is being pushed northward from the Gulf of Mexico with a relentless persistence. We're talking about surface dew points in the upper 60s and lower 70s, which means there's tremendous moisture available for storm development. This is the fuel. The cold front is the trigger. And when that trigger is pulled, the storms that develop aren't going to be typical scattered thunderstorms. They're going to be organized, powerful supercells capable of producing all of the severe weather hazards imaginable. The Storm Prediction Center has identified a slight risk of severe thunderstorms across a massive corridor that stretches from northeastern Colorado and central Nebraska all the way through northwestern and northeastern Kansas. But the risk doesn't stop there. It extends eastward into Missouri. And the concern is that as this system organizes and evolves, the severe threat is going to spread further eastward into the Mississippi Valley. We're talking about a threat area that could encompass 8 different states. That's 55 million people, 55 million Americans, who are potentially in the path of dangerous storms over the next 24 to 36 hours. The specific threats we're expecting are significant and varied. First, there's the tornado threat. Now, at this stage of the forecast, meteorologists are seeing the environment as supportive of strong tornadoes. But the exact probability and geographic footprint of where tornadoes are most likely to occur is still evolving. What we do know is that there will be areas, particularly where storms are strongest and most organized, where tornadoes become a significant threat. These won't be weak tornadoes either. The wind shear profile, combined with the instability in the atmosphere, suggests the potential for strong to intense tornado development. But tornadoes are just one piece of this puzzle. Large hail is another major threat. We're talking about hail that could exceed 3 inches in diameter. Some meteorologists are even using the term giant hail to describe the upper end of what's possible. Hail of that size causes significant damage to vehicles, can break windows, and causes tremendous agricultural losses. If you're in farming country in Kansas or Oklahoma or Missouri, this storm system poses a major financial threat to your crop. The hail cores within these supercells will be particularly strong, and if you're caught in one, it's genuinely dangerous. Then there are the damaging winds. Supercells can produce wind gusts that exceed 70 miles per hour, sometimes even 80 miles per hour in the strongest updrafts. We're also watching for the potential development of a derecho, which is a widespread, organized line of severe thunderstorms that can produce extremely strong winds over a very broad area. Just 2 weeks ago, a derecho moved through northern Illinois and northwestern Indiana, producing widespread wind damage and tornadoes across the region. That event caused significant damage and disrupted communities for days. The conditions we're seeing now could certainly support similar phenomena. Flash flooding is another concern that's being taken very seriously by the Weather Prediction Center. Supercells and organized severe thunderstorm complexes often produce extremely heavy rainfall in a relatively short period of time. We're not talking about a gentle all-day rain. We're talking about the potential for 3 to 5 inches of rain falling in just 1 or 2 hours. When you add that to ground that's already saturated from previous rainfall, you get the potential for significant flash flooding, especially in low-lying areas, near streams, and in areas with poor drainage. Flash flooding is often the most underestimated severe weather threat, but it's also one of the most deadly. The timing of this system is particularly concerning because much of the most intense convective activity is expected to develop during the late afternoon and evening hours on Wednesday, with activity continuing well into Wednesday night and potentially into early Thursday morning. This means that in many areas, the most dangerous storms will be occurring after dark. Nighttime severe weather is inherently more dangerous than daytime severe weather for several reasons. First, visibility is reduced, which makes it harder for people to see approaching storms and to take shelter. Second, many people are asleep when warnings are issued, which means they miss the warning and don't have time to react. Third, tornadoes at night are nearly invisible to the naked eye, making them incredibly dangerous. The metropolitan areas that are directly in the path of this threat include some of the most densely populated regions in the country. St. Louis, Missouri is looking at significant impacts. Kansas City is in the threat zone. Oklahoma City is potentially going to be impacted. We're talking about millions of people living in urban areas that are going to be affected by these storms. The infrastructure damage from widespread wind damage, the interruption to power and water systems, the transportation disruption, these are all very real consequences of severe storms of this magnitude passing through urban areas. Let me give you some historical context to help you understand just how significant this situation is. In April of this year, there was a series of severe weather outbreaks across the central United States that resulted in multiple tornadoes, including an EF4 tornado that moved through Enid, Oklahoma. That outbreak also included a massive stovepipe tornado that struck Vance Air Force Base, causing so much damage that the base had to remain closed for an extended period while crews worked to restore power and water. The Vance Air Force Base event alone demonstrates that when these systems interact with populated areas, the consequences are profound and long-lasting. Earlier in August, a derecho event impacted the Chicago area and northwestern Indiana, producing not just damaging winds, but also tornadoes that caused significant damage. The recovery from that event is still ongoing in many communities. Now, less than 3 weeks later, we're facing a similar or potentially even larger threat. Some meteorologists are actually comparing the atmospheric setup right now to some of the most significant severe weather events from recent years. What makes this particular system especially interesting from a meteorological standpoint is how quickly it's organizing. The conditions for severe weather are coming together rapidly. When meteorologists are forecasting severe weather several days in advance, there's always uncertainty because conditions can change. But when we're within 24 hours of an event, and we're still seeing this kind of severe weather threat developing, that's when forecasters have the most confidence in their predictions. We're at that point now. The Storm Prediction Center's confidence in widespread severe weather is quite high. The geographic area from which the strongest storms will originate appears to be in the high plains, particularly in areas of northeastern Colorado, western Nebraska, and northwestern Kansas. This is where we'll see the initial convective initiation along the dry line and the frontal boundaries. As the day progresses and the sun heats the surface, storms will begin to organize and intensify. By the late afternoon and early evening, we should be seeing the development of organized supercells with rotating updrafts capable of producing strong tornadoes. The storm progression is expected to move from west to east, which means that areas in Kansas and eastern Colorado will be impacted first, roughly in the late afternoon. As evening arrives, the threat will spread into Missouri and potentially into Illinois. By Wednesday night, the most intense activity could be occurring over the Mississippi Valley states, including areas of Iowa, Wisconsin, and potentially even into the upper Midwest. This eastward progression means that the threat window is extended over a long period of time, and different areas will experience the peak of the threat at different times throughout the evening and night. One particularly concerning aspect of this forecast is the potential for storms to remain organized and severe for an extended period. Normally, as storms move away from their source of instability and moisture, they begin to weaken. But in this case, the wind shear profile is so strong and the environmental setup is so favorable that storms could potentially maintain their intensity and organization for many hours as they move eastward. This would create a scenario where the severe weather threat is not just localized to one particular area, but is spread across multiple states in multiple hours. The moisture coming up from the Gulf of Mexico is exceptionally abundant. Meteorologists have been monitoring the atmospheric moisture patterns, and the amount of water vapor available for storm development is well above normal for this time of year. This abundant moisture means that storms will have access to plenty of latent heat energy, which will fuel their development and intensification. It also means that any storms that form are going to have a ready supply of precipitation to work with, which increases the flooding and hail potential. The instability in the atmosphere, measured by what meteorologists call the convective available potential energy, or CAPE, is expected to reach quite high levels across portions of the central and southern plains. CAPE values indicate how much energy is available in the atmosphere to fuel thunderstorm development. Higher CAPE values generally correspond to stronger updrafts and more intense storms. The CAPE values being predicted for Wednesday are in the 2,000 to 3,000 joule per kilogram range, which is exceptionally high. For context, CAPE values above 1,500 are considered quite favorable for severe thunderstorm development. We're expecting values nearly double that. The wind shear, which is the change in wind speed and direction with height, is also exceptionally strong. Wind shear is essential for organized storm development. Without sufficient wind shear, storms tend to collapse on themselves as rain-cooled air falls through the center of the updraft. But with strong wind shear, the updraft tilts and the rain falls away from the updraft, allowing the storm to remain organized and intensify. The wind shear profile we're expecting is textbook for supercell development. All of these ingredients coming together simultaneously is what has meteorologists genuinely concerned. This isn't a marginal situation where we might see a few scattered severe thunderstorms. This is a setup where widespread severe weather is essentially a certainty. The question isn't whether severe weather will occur. The question is how severe it will be and exactly where the strongest impacts will be felt. The preliminary outlook from the Storm Prediction Center suggests a moderate to high risk of severe weather across portions of Kansas, Oklahoma, Missouri, Iowa, and potentially extending into Illinois and beyond. When you see the words moderate risk or high risk coming from the Storm Prediction Center, that's when you know conditions are particularly favorable for organized and dangerous severe weather. These risk levels are reserved for situations where meteorologists have very high confidence in significant impacts from severe thunderstorms and potentially widespread damage. For residents in the threatened areas, preparation now is absolutely critical and non-negotiable. This isn't something you can wait to think about when you see a warning on television. By the time a warning is issued, storms are already imminent or occurring. Preparation means reviewing your severe weather plan now, making sure you know where you'll go if a tornado warning is issued, ensuring that everyone in your household knows the plan, and making sure that you have multiple ways to receive weather warnings. This could mean having a weather radio, checking your phone for emergency alerts, or having a plan to listen to local radio or television stations. The timing of this threat is particularly challenging for emergency management and for individuals trying to prepare. The most intense activity is expected to occur during the evening and night hours, which means visibility will be reduced. And many people will already be indoors. This is actually a mixed bag. On one hand, people being indoors provides some shelter from the storms. On the other hand, if people are asleep when storms arrive, they might not receive or hear warnings in time to seek appropriate shelter. Communities across the region are beginning to prepare. Emergency management officials are reviewing their protocols, hospitals are preparing for potential influx of injuries from severe weather impacts, and utility companies are positioning crews and equipment in anticipation of potential widespread power outages. The coordination required to respond to a major severe weather event is extensive, and these preparations are already underway. Looking at the broader context of the 2026 severe weather season, this outbreak represents another significant event in what has already been an active year for severe weather. We've had multiple tornado outbreaks. We've had derecho events, we've had hail events producing tennis ball-sized hail, and we've had significant flooding events. This particular system is being set up to potentially rival some of the most significant events we've already seen this year. The atmospheric science underlying all of this is fascinating when you step back and look at it. The jet stream position, the location of high and low pressure systems at the surface and aloft, the interactions between warm and cold air masses, the availability of moisture, all of these factors have come together in a very specific way that produces this severe weather potential. This is why meteorologists spend years studying atmospheric dynamics, because understanding how these different elements interact allows them to forecast severe weather with increasing accuracy. For those watching this who live outside the immediate threat area, this event is still worth paying attention to. If you have family or friends in the threatened states, reaching out to them to make sure they're aware and prepared is valuable. Social media and news organizations will be providing extensive coverage of this storm system as it develops. And if you have any professional interest in meteorology or severe weather, this is the kind of event that provides tremendous learning opportunities. The potential for atmospheric research and storm chasing from this system is also quite significant. Professional storm chasers and meteorologists from universities and research institutions will likely be positioning themselves within the threat area to collect crucial data from the storms. This data is invaluable for improving our understanding of severe weather processes and for improving forecast models in the future. Every significant severe weather event teaches meteorologists something new that can improve future forecasting and warning capabilities for years to come. As we move through the remainder of Tuesday and into Wednesday, meteorological updates will become increasingly frequent and more refined. The Storm Prediction Center will be updating its outlook multiple times, and local National Weather Service offices will be issuing more detailed specific guidance as they can resolve the forecast more precisely. The window of time between now and the actual event is absolutely critical for preparation, communication, and ensuring that people in the threatened area are aware of the threat and know what actions they need to take. The broader implications of severe weather events like this extend beyond just the immediate impacts of the storms themselves. There are economic impacts from damage, there are psychological impacts on communities that experience severe weather, and there are long-term recovery considerations. Communities that have been impacted by recent severe weather in the region are particularly concerned about facing another significant event so soon after the last one. In conclusion, what we're witnessing in the atmosphere right now is a setup that meteorologists recognize as having the potential to produce significant severe weather impacts across a very large geographic area. The combination of abundant moisture, strong upper-level winds, a favorable jet stream position, and strong surface temperature gradients creates an environment where powerful supercells and potentially organized severe weather complexes are going to develop with near certainty. For anyone in the threatened areas, now is the time to ensure preparedness, to review your severe weather safety plan, and to stay informed as updates and forecasts evolve over the coming hours. This is a situation that deserves serious attention, deserves respect, and demands careful preparation from everyone in the path of these storms. The meteorological community is watching this system closely, and as it develops, more specific guidance will become available. Stay alert, stay safe, and take this threat seriously.